G'day ladies and gents, this is Kai for War Thunder Explained. Today we will be looking at some shell types and focusing on how and why their trajectories and penetration values are different. There are two categories of shells currently in game, and indeed also developed in real life, and we will walk through each one by one. There are kinetic energy and chemical energy shells. At their simplest level, they explain how the penetration of enemy armor occurs. Kinetic energy shells use their weight and speed to have the highest kinetic energy possible, and therefore the highest penetration values possible. Chemical energy shells use explosions or other chemical processes to penetrate armor rather than kinetic energy, and usually do not have a large focus on the speed of the shell. Today we will start with the AP line of shells, or armor-piercing shells. These are a type of kinetic energy shell and typically come with a variety of caps, or layers, that are purpose-made to increase the penetration power of the shell. The standard AP shell is a pure kinetic shell, and was often used by early World War II anti-tank weapons. These shots require precise placement, and do much of their damage from the spalling or breaking of internal surfaces. APC, or armor-piercing capped shells, have a nose cone of softer metal which allows for the normalization of the shell against the enemy armor to both prevent shell shattering and bouncing. This means that these shells are capable of penetrating enemy armor at higher incident angles more reliably than just standard AP shells. APBC, or armor-piercing ballistic capped shells, use a more aerodynamic cap to allow for higher velocities and therefore better penetration capabilities. It is worth noting that unlike APC shells, the cap does not directly provide higher penetration values on impact. It simply allows for the shell to keep more of its energy on its path to the enemy armor. APCBC, or armor-piercing capped ballistic capped shells, use a combination of both caps to reach the ideal for AP shells. The ballistic cap helps during the approach of the shell, breaks away on contact with enemy armor, where the APC cap then takes over to normalize the shell and aid in the redirection of the shell's velocity vector to reduce the angle of the shell on the armor and prevent shattering and bouncing. For all these shells, an explosive filler can be introduced into the core of the shell, resulting in an APHE designation. Thus, APHE, APHEBC, and APHECBC can all exist and are found on various vehicles. By the end of World War II, most tanks were using either APCBC or APHECBC, or some variation of it. There are also some vehicles, like the Chiha Long Gun, which is simply a naval gun mounted on a Chiha chassis, that uses SAP shells, which are semi-armor piercing shells. The Chiha Long Gun, for example, uses namely the SAP-HE-CBC, which uses a lower quality or lower performance steel to lower the penetration power while increasing the explosive payload that the shell carries. These shells were common on ships to reduce the likelihood of over-penetration on the target. Finally, the last types of shells are called sub-caliber AP rounds, which use the entire caliber of the gun to shoot, but result in a sub-caliber penetration, due to the penetration of the shell being done by a smaller core inside of the shell. These are most commonly referred to as discarding sabot shells. APCR, or armor-piercing composite rigid, although it doesn't seem to be a discarding sabot shell at first glance, does technically belong in this category, as it uses an extremely hard tungsten carbide alloy as a sub-caliber penetrator that a softer full-caliber sabot carries to the target. Although these shells have particularly poor angled armor penetration performance in-game, they tended to have on-par penetration when compared to various AP cap shells in live-fire tests. In fact, they seem to penetrate more at short distances, but would drop off in performance faster than AP shells at range. However, unlike AP shells, they suffer from low post-penetration damage that tended to be highly concentrated due to its low effective caliber. APDS, or armor-piercing discarding sabot, fixes most of the issues that the APCR shell faced. Instead of using the sabot during the whole trajectory of the shell, APDS shells discard their sabot right after exiting the barrel. This results in an extremely high velocity, usually very dense shell that has very good penetration values, and much higher ranged penetration values than AP shells of the same caliber. APDS shells do have a tendency to shatter when used against armor close to the shell's maximum effective penetration values, and the thicker the armor, the less post-penetration damage it will cause. Finally, APFSDS, or armor-piercing fin-stabilized discarding sabot shells, were created and constitute the pinnacle of kinetic energy anti-armor shells. APFSDS works in the same way as APDS shells, but are fin-stabilized to aid with the energy retention and ballistic trajectory of the shell. These shells also have a longer armor-piercing core, which improves post-penetration damage on enemy armor. Thank you for your attention. I hope you learned something.